Today, we're going to talk about something that feels like it came out of science fiction, but actually, it's very real: space time. Hi, I'm Andrew. I'm a physics major and enthusiast, and I focus on making complex ideas understandable, removing the anxiety, and just enjoying the truths that are found in these mysteries. So if you were ever confused about physics or science, then you're in the right place. Now, let's move on to space-time. What is it? Well, it's the fabric that holds the universe together. It's not just space and not just time, but it's both. Einstein shattered this idea by showing us that they're intertwined. Space and time form a four-dimensional continuum, and anything with mass, from stars to planets, bends and warps it. Imagine dropping a bowling ball in a trampoline. That's exactly what happens when the Earth distorts space-time. Space and time are linked together. When something as big as the Earth sits on space-time, it creates a distortion. It bends space-time. Anything caught within that bend begins to be pulled towards the Earth. That's gravity in action. Gravity, everyone knows about it, but not everybody knows why things fall. It's not some magic force pulling things down. It's space-time bending under mass. Let's go back to the trampoline example. When the bowling ball is sitting in the center of the trampoline, it's bending the surface. Because our sun is much bigger than the Earth, it's creating an even bigger dip, an even bigger distortion. And that distortion encompasses not just the sun, but all the planets in our solar system. So it's a massive dip, and all the planets are held in place by that huge distortion. That's another way of thinking about gravity. Now, black holes. These things is where gravity goes wild. A black hole is a place where mass is so dense, not even light can escape. It warps space-time beyond what we can even comprehend. Imagine the fabric of space-time bending so much that it creates an infinite hole. And because space-time is so twisted around black holes, time itself begins to slow down. The closer you get to a black hole, the slower time gets. You could theoretically be near a black hole experiencing seconds, while somebody very far away will be experiencing years. Black holes don't just suck up matter. They make time behave on its own schedule. Now, this brings us to our next point: time travel. Yeah, it's possible. Theoretically, sort of. If you could travel near the speed of light, then time for you would slow down relative to somebody else. You would age slower. It's not exactly time travel, but it's a form of time travel forward. Time moves differently the stronger the gravitational field, and that's a consequence of how space-time warps. So in theory, you could travel to the future, but it's not as easy as jumping in a DeLorean. The speed you need to travel is near the speed of light, and that's technology no human has. So that's space-time. It's what makes the universe tick. It's why gravity exists and why black holes bend everything, including time. It is a complex idea, but once you begin to understand it, you'll begin to see it everywhere. You'll begin to understand how it's woven into every aspect of reality. And when you begin to think about space travel, future technologies, maybe life in the universe, you're going to take space-time into account. And that's a very huge factor when you're thinking about these ideas. Thanks for watching. Now, if you have any more questions or thoughts or ideas about space, physics, or science, hit the subscribe button and let me know what you want to learn next. Until next time, keep looking up.